Hello everyone. So today we are going to create this third person character from scratch using C++. So actually this is what we get at the end. This is this third person character. We already have this character in Unreal Engine, but we are going to using the same skeleton. We are going to build the character movement, character inputs, and camera inputs and jumping. So those basic things from scratch with C++. So the reason is I got multiple requests on cover some of C++ topics in Unreal Engine. So yeah, I thought it's a good topic to have. And this episode is by these generous patrons. Thank you very much for your support. Right, so let's open Unreal Engine and let's create a new project. I'm gonna select games, and actually for this I'm gonna select the third person template because we don't have a we can use this uh, character skeleton for our character to test. And here select C++. I don't need starter content for now. Okay, so let's name this code like me CPP. Okay, now let's wait for the project to open. So by the way, I have installed here I'm using Unreal Engine 4.25, and I have also installed Visual Studio 2019 with uh, support for game development as in this documentation. So with this game development with C++ and on Visual Studio 2019. Okay, right, so the engine is open, the project is open, and also the Visual Studio is also open, but it doesn't have anything. So let's create our first class. We have this class actually code like my CPP character because I selected third person template, and if I play this we can play with this character. So actually, right, but I'm not going to use it. I'm going to create our own character from scratch because we need to learn how to use we need to be how to develop with C++. Okay, so let's create a new C++ class. I'll use the tag character template, and I'm pretty sure you are already familiar with this if you have followed any, if you have basic knowledge in Unreal. So basically character is a type of pawn that includes ability to walk around, type of pawn. So pawn means and that actor can be possessed and receive input from a controller. That means a character is something that we can control using our keyboard and mouse, or whatever the input device, and which can also walk around in the game world. Let's select this, and here what's the name? CPP TP. CPP stands for third C++, and TP stands for third person character. Now let's call it CPPCH. CPP character. Okay, and create. Now it's compile in C++ code. So let's give it a minute. Okay, and it is working. Oh, and we have errors. Well, actually, I think there are some bugs in this Visual Studio. So after we create in the project, no, still this is initializing, but we have some errors. So right, so I just did some research before, so how to get rid of this. So what is suggested is close both project and the Visual Studio. Let's open it again just in case to see if it works. Ah, now the errors are gone. Okay, good. Oh no, not gone. Okay, let's close this and refresh Visual Studio 2019 project, and let's see if those are gone. Okay, so now we have this. If I go here and build solution, or we can use Ctrl Shift B, and let's wait it to build. Okay, now it has been built, and if I drag and drop this, you can see just like with the third person character with we have created with blueprint, we have this skeletal mesh and the character movement component, which inherently comes with the character. So these are by default, these three components, capsule, mesh and the character movement, they come by default for any character class we create. So here we can use mannequin, and I'll rotate it 90 degrees. Oh sorry, select the mesh and rotate minus 90 degrees and move down minus 90. Yeah, looks right. Okay, but so what about adding these cameras and other stuff we need? Okay, let's first add a camera component. Right, so to add a camera component, we have to use first we need to include the header file which contains details about the camera. Otherwise this character class will not know about the details of those camera components and all other stuff that we need to include. So that's basically how C++ works. So, and also one more thing, when we create a class we have this .h file and .cpp file. So this h file is called header file. So actually I'm assuming kind of you have some knowledge in programming languages, so I'm just briefly saying these things. And the C plus cpp, which implements whatever we define in this header class. So this header class is like the definition of this class, and this is like the implementation of this class. So yeah, so here first we need to add a camera. So usually we don't add a camera, we add a first add a camera boom and then we add a camera. So let's see how to do that. Okay, so first, to add a camera boom, we need to add a spring arm component to this class. The spring arm component is defined in the game framework header file. So we have to include, so whenever we include stuff, we should include it before this generator.h header file include. I'm not sure what the reason is because I read it somewhere. Okay, hash include, and we are not getting any suggestions. See, okay, so let's make these suggestions work. If the suggestions are working on your PC, then it's fine. Otherwise, so this is what I have to do usually. Go to nmake, and here include search path. We have to give the folder where we have the classes of Unreal Engine. So go to your install location of the Unreal Engine and engine source runtime again engine and classes. So here we have these components and interfaces, layers, everything. So copy this and go back here and use it like this. So you will be able to include this with the environment variable, using environment variable as well, and also use the path that is relevant to your PC. Apply, and here now we can see some things are happening. Now I think it is initializing those included classes. So we will have to wait until this is done. Okay, it seems done. Hash include game. So one more thing. So I don't know why, but when I try to include with this within this these marks, it doesn't show me the suggestions, but I can include with this mark game frame work like this and spring arm component. Okay, now that we have included spring arm component, we can define a property to keep a reference to the spring arm. So let's go to this public, and after ACPP character constructor definition, let's add a u property, and here we can add visible anywhere. So this allows us to see this property we are defining here in blueprint. So in the detail panel of the editor, when we select this component, select this actor, right, and let's make this blueprint read only. I'm not sure what that, and the category, let's say camera. Now let's define the spring arm. Let's wait for the suggestion to appear. Okay, use spring arm component. Now this is a pointer. Camera boom. Right, so this is a pointer. That's why we use this asterisk mark. So pointer is a variable in C++ that holds the address of another variable. So basically this camera boom pointer will have a reference to the actual we can use it to have a reference the actual spring arm component. So right, and also we need a camera component too. So yeah, in order to define a camera, first we need to include camera header file which contains details about the camera. So it's camera component like this. So even if we use this mark or this mark, it both works. So I'm using this because I don't get the suggestions with if I use this. And right, another U property. So I'll copy this. Camera is also another U property, and I'll make it visible anywhere. Blueprint read only. Category camera. So this must be your camera component. Let's wait for the suggestion to appear. Okay, and a pointer. This is also a pointer. Let's call it camera. Right. Oh, let's call it something like player camera. Okay. Now just because of we do these things, the camera will not appear in the editor. Just to see that, let's build this with Ctrl Shift B and see what are the changes we can see here. See, still we don't have anything. Okay, and also let's make this character playable using this auto possess player 0. So if I play the game, well, nothing happens because we don't have a camera, so we will be seen like this. Okay, now we so far we only have a reference, a pointer to camera and a pointer to camera boom, nothing else. Right, now let's go to this character cpp character class, and here let's initialize these variables. So how do we do that? Like this. First we need to create objects for actual objects for this camera boom and for the player camera. Let's do that in this constructor. So if you don't know what is a constructor is, it's a special method that is automatically called when an object of class is created. So when we create a cpp character object in our editor, this constructor acpp character will be automatically called. So this begin play will be called only when we start playing the game. So here, this is the best place to create camera objects. So how to create a camera object? Like this. Camera boom equals create default sub object. So this object type is going to be a spring arm component, and the name we are going to call it is camera boom, and that's it. Did I miss anything? No. Okay. Sorry. This should be within this. This is a text, so we should have that. Okay. Text should be within quotation marks. Okay, so that's the camera boom. And also let's create no wait, we should attach this camera boom to the root component of the character. Otherwise, like it's not like just like drag and drop in Blueprint. We have to define these things when we work with C++. So camera boom setup attachment, and so we are going to attach it to root component. Okay, now shall we build and see if we have a camera boom. Select the character. See, now we have a camera boom. Okay, now let's attach a camera. So first we need to create a camera object. Player camera equals create default sub object. It should be in the type of view camera component, and let's call it player camera, text player camera, right? And this camera should be attached to the camera boom. So player camera setup attachment. So we are going to attach this to the camera boom, and also we need to define which socket we are going to attach. So we can access the default socket names of a spring arm like this. Use spring arm component socket name. So it will be, the camera will be attached to the end of the spring arm. Let's build this and see. Now we have a camera attached to the character. Okay, we are putting together our character piece by piece. See, now if I play the game, we can see the character, but we can't still move or look around or anything. Okay, right. Now let's see how to let's see how to look around with the camera. So actually, since we have used this default third person template, we already have inputs defined here like this. We have actions, jump and reset VR, axis, move forward, move right, turn, look up right, and look up. So these are the we in order to look around, we have to use this turn and look up axis. So how to use that? Let's go here. Right here, when we go to the character class, CPP character class, here we have setup player input component function. We have this by default. So here we can bind inputs to our character like this. So basically, you know, in blueprints we can have we can add rotation inputs using axis. So here we can bind it like this: player input component bind axis. So here we are going to bind this turn. This is this is like look left, look right. We can do that with this turn axis. So turn, and we are going to bind it here. Use object. First one is axis name, second parameter is object. So we are going to bind to this object. And what else we have? T base delegate. Okay, so here we have, actually, since we are this class is inherited from a character. You know, character is inherited from pawn. So in the pawn we already have controller your input methods. So add a pawn, add controller your input. Okay, so we should be able to look to the left and right with this part. Let's build and see. Oh, now we can look to the left and right, but also character is moving. Character is also rotating. That's because if I select this, can we see those things here? We have this use pawn control rotation. It is disabled, right? Oh no, sorry. So we have to disable that. Okay, we can do usually in a character blueprint we have that of those options to make to define whether to use controller rotation pitch or roll or yaw when we select the blueprint in the detail panel. But since we are using C++, let's go to the code and let's tell our class to not to use those things. So B use control rotation pitch to false. Actually, I don't need it to use any of them. We use control rotation roll to false, and we use draw rotation yaw to false. And also one more thing, we need our character to rotate to the direction character is moving. Maybe let's do that later. Okay, now let's build this and see. Oh, it's still not gone. Well, actually the problem is, even if I build this, the hot reloading is not happening for some reason. I'm not sure what the reason is. So anyway, let's close this and open it again. Let's do some changes and compile again. No, still hot reload didn't happen, because if that happened, I will get a click click sound. So let's restart the project maybe. Okay, right, so I restarted the project and it is not working. Okay, and once I select this here, we can see this use phone control rotation for the camera boom, and yeah, so if I enable that here, it works like this. And also I have disabled these use control rotation pitch roll and yaw for the character, so character is not turning as I look to the left and right. But so if I disable it right here and if I enable it through the code like this, camera boom use phone control rotation true. Let's compile it. And now still if I select this, this is false. Why? Oh, let me drag and drop again. Alright, now it is enabled. Okay, I think that's because I override it here. Oh, yeah, so whatever I define here, if I comment this and build here, this false is the default option. Now if I uncomment this and build, true is the default option. See, that's why we get this one. So let's leave the default option. We don't need to override anything here because we are controlling stuff through the code. See, now I can look to the left and right. So similarly, let's see how to look up and down. So for that we have to use this lookup input, and let's copy paste this look up and a pawn add controller pitch input. Now build, so I should be able to look up and down. See, okay, now we can look left and right, up and down. So how to implement movements? Well, let's go here. So in order to implement movements, we need two more methods. So we have under input move forward and move right. So actually we don't need to have the same name functions, but we need two functions. So we need to define functions first in the header file, then we have to implement them in the class file, cpp file. So okay, let's define two more functions. Void move forward float axis and similarly move right. Now this parameter should be float, so we need to implement this in the cpp file, but we can easily do that automatically here. Create definition of move forward in cpp character cpp, click that, and Visual Studio will automatically create the function like this. See where? Okay, see, now we have that function. Let's do the same for the move right as well. Okay, I'll cut this and move it down because these functions are more important. Actually I first had them. So okay, so move forward. So with the move forward, first, just like we bind the way we bind the add controller pitch input and your inputs to look up and turn, we need to bind these two functions to this move forward and move right axis. So how to do that? Well, just like we did here, bind axis, move forward this. So here actually we need to bind to this function, so let's copy this. Okay, and similarly move right. Make sure the whatever we type here, this axis name is same as the one defined here. Move right. Okay, now when with the axis value of the move forward and move right, these two functions will be called, but still our character won't move even if I press movement buttons. See, yeah, that's because we still haven't implemented these functions. So how do we add a moment input? So for that, first we need to find the direction. First we need to get the direction of the controller, that means the direction that we are looking through the camera, and then when I press W, we should apply a moment input along that direction. If we press A or D, we should apply a moment input using the right vector of the controller. So we will move to left or right. So how do we do that calculation? So usually what we have to do is get the forward vector of the controller, and then actually we only need to have the direction in the horizontal plane, So we will not apply any movement input upwards or downwards. So we need to get the component of the forward vector of the control direction in the horizontal plane. So I know that's not clear, but this is how we do it. So for this we need to have a constant. So the constants are not like unlike variables. The values in constant we don't change later. F rotator, F rotator, it should be simple. Yeah, F rotator, rotation. So actually this is the control rotation. So we can get it like this: controller get control rotation. Okay, now we only need the yaw part of this, because we need the we need to find the direction in the horizontal plane. So let's have another constant, F data control yaw only. So we can define it like this: F rotator 0, and for the yaw part we need to use control rotation yaw, and for the pitch part also, roll part also 0. Right, now here we have the control rotation only with the yaw part. Now we can calculate the forward direction of the controller like this: const f vector fwd equals, so because we are going to calculate the forward, f rotation matrix here, control rotation yaw only, and from this get unit axis, not axis, axis, e axis x, because we need the forward direction. Right, now we know the forward direction. Now along this direction we should apply a moment input. So how to add a moment input? Well, like this: add moment input. We already have this function defined because this is a character. So fwd, this is the direction, and value is axis. Let's build this and see if it is working. Right, it is working. Okay, now just like this, let's implement the move right function as well. Now here we need not fwd, let me rename this right. Okay, now right is we can use the same thing, but here we should use y-axis. Now build this. By the way, I renamed this here using Ctrl R 2 times. Okay, now I can move left to the right, left or right with A and D, and forward and backward with W and S. So now let's see how to make this character orient to the direction it is moving. So actually it's very simple. All we have to do is we already have a variable to set to true. The variable is here, get how to get character movement. Oh no, we need to access character movement. Get character like this, get character movement, and there we orient, come on, it's hard to code without suggestions. Sorry, I think I have to include the character moment header file here. Yeah, that's the case. So how do we do that? Well, let's hash include game framework character movement component. Okay, now we should have it. Get character movement right, we orient rotation to movement, set it to true. Now let's build this. Okay, now our character is rotating to the direction it is moving. So but still we don't have animations, but since we have used this third person character, we should have an animation controller. So yeah, here third person and MVP. Okay, let's use it for now because I don't have I'm not going to implement the animation blueprint class also with the with C++, so I'll reuse the existing one for now. Okay, now it can move. We forgot one more thing, we didn't implement jump in, and we already have jump input. This is the action, so let's implement that part too. Go here, the way we bind an action is a little different. Player input component bind action, so the action name is jump, and the next parameter is key event. and the events, the key event means we have pressed event and released event. So IE pressed. So when we press the jump button, object is this one, we should use at a character, oh, a character jump. So since we have inherited this class from the character class, we already have this jump function defined in the character class, so we don't need to implement it like this, move left or move right or move forward. So similarly, for the IE released, we can assign jump. There is a jump stop jumping, okay, method 2, but I don't think it's necessary to do that here, because let's see. Okay, now we can jump to. All right, so I think that's enough for today. So yeah, now we have a character implemented with C++ with basic camera inputs and movement inputs with jumping. And okay, that's enough C++ for a day. Right, so as always, project files will be available for the download through the Patreon page. Link would be in the description below. And if you would like to support my work, you can get the membership of the Patreon club. And thanks for watching. See you in another episode. Goodbye. Also feel free to let me know what are the other things that you would like me to cover with this C++ series.